What am I expecting today? Uh, I just want to learn more about cloud, how I can get started in AWS, and I want to be inspired. Uh, Let me think about it. Come back later.
Yeah, so yeah, so I've been learning about security on the cloud, even as many companies are joining in for into cloud, and so I would like to know the security things to do and ways to how to secure yourself from any attack. So I think that is it basically for today. And I think yesterday we learned a lot. Yeah, and I hope we're going to do it practically today though. Thank you.
Hi everyone. Uh, yeah, you're audible. I think I want to learn. Okay, what I expect to learn about cloud is mainly I'm in the areas of AI and IoT. So mainly I'd like to know like data storage, how to use data storage APIs, and then APIs that I can be able to connect my applications to cloud. Yeah, so that's mainly that. I'm sorry I wasn't in yesterday's session, so probably I'm a little behind. Hello. I want to take this opportunity to thank both of you for welcoming me to this grateful program and to bootcamp to enable us to grow our skills in technology. Okay, so my expectation today is I want to know more about cloud computing since hello. Hello. So I want to take this opportunity to thank. Hello. Uh, can you hear me? So my name is Brian Wahungu. I'm a student of information technology. I have finished nearly to graduate this month. So my expectation of this bootcamp is to learn more about cloud computing and the need and how. Okay. And the value and the more how skilled can we go far so that we can be more knowledgeable about cloud computing. That's all I have to say. Okay. Thank you. Thank you. Thank,
Thank you. Wow. Uh, I don't know how to come after this introduction. Wow. But thank you, Albert. I really appreciate that. Yeah, cloud is a really exciting field to go into, and I'm glad that you guys are here, ready to learn, ready to grow. Yeah, let's work on this and grow together. So, without wasting too much time, I have a lot of things installed for you. So, without further ado, let me share my presentation. Mhm.
Can you see my screen?
Yes.
Awesome. So, welcome to day 2 of the Cloud Practitioner Bootcamp. There is a lot we're going to cover today, but yeah, let's have fun as we go into this. So, today's agenda will cover 3 topics. The first is AWS storage services. The second is Amazon Virtual Private Cloud, VPC. And the third is Amazon Route 53. So we'll go in depth into these topics and hopefully help you prepare for the exam. So, okay. Mm, let's begin. But before we begin, I wanted to notify you guys on just a few things. First of all, there will be hyperlinks. Yeah, there'll be hyperlinks in the presentation. So in case you need to do some further reading, or maybe there's something that you don't understand, I've attached the link to an article to help you, get some background knowledge. And these slides will be shared at the end of the presentation. And yeah, without further ado, let's begin with cloud storage. So there are 3 types of cloud storage. There is file storage, there's block storage, and there's object storage. So let's begin with file storage. What is file storage? This is a storage method whereby your data is stored in a hierarchical structure. Yeah. So this storage methodology is useful for structured data. The structure consists of directories, subdirectories, folders, and files. Yeah. If you've used a computer before, let's say your Windows computer, you've noticed that you're navigating through different folders to access your files. So the same concept applies here. Okay. So this is one of the hyperlinks I was talking about. Yeah. Now, the way to access file storage is through certain protocols. This goes into a bit of networking knowledge. So the first, which is for Linux systems, is NFS. NFS basically means Network File System. And if you want to do some further reading, you can just click on that link when you receive the slides. Also, the SMB protocol is used for this access to file systems, but this is in the case of Windows systems, all right? So basically, within file storage, we use paths to access the files, yeah? And let me show you what that looks like. So let's say you want to access this file called objectstorage.txt, yeah? You go to the folder, which is articles, then slash object-storage.txt. You see, that's a path. That's what I mean by a path. So article slash object storage.txt. All right. Then the use cases are for local file sharing. Let's say you have your own company's internal network and you have many users, yeah, many computers, and you want a centralized file system. File storage is ideal for this use case. Then let's say your company is working on a project where a lot of people are really collaborating and editing certain documents. Yeah, you need a central repository where you can organize or rather centralize your project execution. So a file storage system is ideal for that. So some examples that you're familiar with of file storage are Google Drive and Microsoft OneDrive. All right, now let's deal with block storage, okay? This is a storage method whereby the file itself is broken down into chunks that are called blocks, Okay. So each block has a unique identifier and is stored separately. So how it works, if you want to access the file, the operating system actually uses these identifiers to pull the blocks back together to become the file. Yeah. So this is way faster than file storage because you're not navigating through directories. So when you require workloads to deal with workloads that require low latency, for those of you who don't know what latency is the amount of time you get a response for any given request. Yeah. So when the latency is low, meaning that it takes less time for your response to return after you send a request, that's good. But if the latency is high, uh, yeah, that's when you start to experience performance issues. Yeah. So block storage, low latency. So this is how block storage typically look, or rather works, an analogy of how it works. So the file is divided into blocks which have unique identifiers. Yeah. So the protocol typically used to access block storage is iSCSI. This is just an acronym for Internet Small Computer System Interface. Yeah, I know it's a mouthful, but I've left you a hyperlink in case you want to read further into that. At least it will help you move from that place of uncertainty. So the use cases for block storage, you typically use them in transactional databases. This is whereby you're having a lot of read and write operations. Yeah, you need a storage that can be able to withstand that. So block storage is ideal for that case. Then you also use it for storage as a storage option for critical business applications. You remember us talking about low latency being a good thing, that the amount of time the response to your request takes is minimal. Yeah. So it's ideal for critical business apps that require low latency. So an example of block storage that you've probably come across is a local disk. Now to object storage. So object storage is a storage method whereby your data is stored as distinct units. Yeah. And these units are called objects. So what an object is basically a piece of data that's bundled with the unique identifier and metadata when stored in object storage. Metadata is a really crucial feature for object storage because it allows it to be searchable. Yeah, you can apply SQL queries to your data and be able to search through it. So another unique thing about the object storage is that objects are stored in a structurally flat data environment. You remember how in file storage we dealt with hierarchies. Now in object storage, there are none. It's just flat. It's just your data. Yeah. So you access object storage typically through HTTP, which is Hypertext Transfer Protocol. You can read that article. And also APIs, application programming interfaces. Yeah. If you need more information, you can see that link. So the use cases for object storage. Yeah. Object storage is ideal when you need to store your backups. Yeah. You need long-term storage of your backups. Object storage is really ideal for that because it's highly durable and redundant. excuse me. It's also suitable for storage of your archives. Archives are basically the data that you keep for the long term, that, historical data that is not really accessed that frequently, but is kept as a record of maybe previous transactions or for compliance purposes, right? Then large amounts of unstructured data. Yeah, that's really ideal, an ideal use case for object storage. Also, static files. We'll look into hosting a static website on Amazon S3, which is the Amazon service for object storage. So static files are really can be stored in object storage very efficiently and accessed very easily. Also, videos and images. If you're a Netflix subscriber, then you see all those movies that you watch all the time, yeah? They're stored in object storage in S3, then yeah, you access them. All right, now we move to AWS storage services. So what I've just taken you through was a conceptual view of how cloud storage looks like. Now we go into the specific services. All right, so for block storage, we have two services. There's Elastic Block Store, EBS. There's also EC2 Instance Store. All right, I'll handle each of these in detail. For file storage, we have the Elastic File System, EFS, and also Amazon FSx. Object storage, we have the Simple Storage Service. It's called S3, I guess, because it has 3 S's. Yeah. So now Amazon EBS. Let's go through a few definitions first. What is an EBS volume? It's a durable block level storage device that you can attach to your EC2 instance. Think of it as maybe an external hard drive that you attach to your computer. There's also the EBS snapshot. This is a point-in-time copy of your EBS volume, which is stored in S3. All right, so you have your volume, yeah? And you want to take a backup of it. You take a snapshot, which is a point-in-time copy, and store it in object storage in Amazon S3, right? Then data lifecycle manager. Now you see you've created your snapshot, yeah? But you really don't want to go through the mundane tasks of going about taking snapshots of different EBS volumes in your work environment. It's quite tedious. So you want something that will automate the process. So your data lifecycle manager actually automates the creation, retention, and deletion of EBS snapshots using lifecycle policies that you yourself define. More characteristics of EBS. EBS is persistent storage, yeah? Meaning that the data persists independently of the life of the instance. I assume you've already handled compute yesterday during day one. So, but for those of you who aren't there, an instance is basically a virtual machine. An EC2 instance is a virtual machine in AWS. So once that virtual machine is terminated, the EBS volume is left behind, hence it's persistent, right? So you can attach multiple EBS volumes to an instance, and also under very specific constraints, though this is not too relevant for the exam, this is just for your information. You can use EBS multi-attach to attach multiple instances to one EBS volumes, but you have to fulfill the constraints. But that's out of the scope of this cloud practitioner exam. So this is something to note. Root volumes of your EC2 instance are deleted on instance termination by default. Yeah, there's a place in the console that you can take termination, deletion upon termination. So for root volumes, these are deleted by default. But for non-root volumes, other volumes that you add to your EC2 instance that are not the root volume aren't deleted by default. Remember, I mentioned persistent volume, persistent storage. All right, so periodic snapshots of an EBS volume are incremental. Let me tell you what incremental means. So you remember the snapshot we talked about. You take a snapshot of your volume. Then let's say maybe a few minutes later, there's some new data added to your volume. And then you take another snapshot. So what will be recorded is the blocks that have been changed, and that is added to your snapshot, hence the word incremental. So only the changed blocks are added to the snapshot. EBS volumes are specific to an availability zone. Yeah, the availability zone specific. All right, keep that in mind for the exam. EBS snapshots are specific to a region, but can also be copied to a different region for disaster recovery. Right? So you remember we are using EBS snapshots for backups. So we store them in S3, but what happens if maybe that region undergoes an earthquake or undergoes an outage? What happens to your backup then? What happens to your system then? So if you store your snapshot in a different region, then you have a solid disaster recovery strategy, a multi-region strategy in case of the failure of one region. Snapshots can be used to create Amazon machine image. All right, this was probably handled in the previous class. But for those who don't know what an Amazon machine image is, it's basically, you see, the virtual machine that you create, the EC2 instance with all the applications and everything. You can store a template of that machine or that virtual machine. That is called an Amazon machine image. Yeah, an AMI, right? So EBS volume types, all right? So note that these two volumes are the only ones that can be used as boot volumes for your EC2 instances. So there's general purpose SSD that involves the GP2 and GP3 models. So the general purpose volumes basically balance price and performance. Yeah. So they're, general purpose, as the name suggests. They are viable for a wide variety of workloads. Yeah. Right. So there's also provisioned IOPS. IOPS meaning input output operations per second. Yeah. So provisioned IOPS SSD. Okay, SSD means solid state drive for those who maybe weren't aware. The models are IO1 and IO2. So this provides high performance for low latency and throughput intensive workloads. So if you have those business critical workloads, it would be advisable to use provisioned IOPS, since they help you, they provide those additional IOPS to your general purpose, yeah, in case your workload scales. So this is recommended for mission critical workloads, yeah, as I said, the business critical workloads. All right, so moving to the HDD, hard disk drives, yeah. So there are two types. There's throughput optimized, the ST1 model. This is suitable for frequently accessed and throughput intensive workloads, right? Yeah. Then now to the cold HDD, which is the SC1. This is the lowest cost HDD, and it's used for infrequently accessed workloads. All right, now to EC2 Instance Store. This is also another version of block storage, as we had mentioned before. So the difference between EBS and EC2 Instance Store is that the Instance Store volumes are physical high performance local disks that are attached to the host computer. Okay, let me break that down. Assume this, if you can see my cursor moving, assume this, is it blue? I'll call it blue. This blue circle is the server in which your virtual machine or your EC2 instance is being hosted. Yeah. So let's say you stop your instance and you restart it. There's a very high likelihood that it will not be on the same host. It will probably be launched on a different host. So since instance store volumes are physically attached to the host, you see, if your instance has moved to another host, then what happens to your data? It's lost. Yeah. So that's why it's temporary. I use this word ephemeral, or yeah, ephemeral storage. So you'll hear this a lot when you're studying for the certification. This basically means that the storage is temporary. Yeah. So the advantages of an instance store are high input-output performance. It's also ideal for your temporary content. Yeah. If you want to store buffers, cache data, scratch data, yeah, you should look at EC2 Instance Store. Now, it also has its drawbacks. The biggest drawback is that, as we said, the data is lost on termination. It also can't be resized since it's a physical disk. Yeah, it has a finite capacity. Also, the backups must be done by you, the user. Right, now to the file system, Elastic File System. EFS is a managed file-based storage system. Yeah, as we mentioned before, you remember what a file system is. It uses the NFS protocol, Network File System Protocol. Yeah. So the thing that makes this type of storage unique is that you can connect multiple EC2 instances simultaneously to one file storage system, and all these users can work on those same files together. So instances can connect to it from multiple availability zones. I'll show this in a diagram. Other VPCs and on-premises. Just keep that in mind. It's only available for Linux. Yeah, this is very important. Now, this is the diagram I was talking about. So you have your EFS file system, yeah, and you have your compute instances in different availability zones, yeah. So you can connect all these instances to the same file system, yeah. Use a mount target, something that's called an EFS mount target, to connect to the EFS file share. Even your on-premises servers can connect to the file system through either direct connect or VPN. Yeah, so keep that in mind. Amazon FSX. I don't know what the acronym FSX means. Maybe someone can write it in the chat. But FSX is mainly suitable for your high performance file systems. Okay, so if you have a cluster of compute instances like EC2s, like these virtual machines that perform very high performance computing operations. And you need a file system that can be able to serve those operations. You'd use FSX, sorry. So this is a fully managed service that lets you launch third-party high-performance file systems. So at this level, you basically need to know two of these, which are FSX for Lustre. This is basically for Linux high-performance computing workloads. Lustre is basically Linux cluster. Yeah. FSX for Windows, which is for high performance workloads for Windows instances. Then these are others that if in your own time you want to do some further reading, you can read on them. Now to object storage, Amazon S3. S3 is a fully managed and serverless. By serverless, we mean you don't deploy or manage any instance to operate this service. So S3 is a fully managed and serverless service that provides object storage. S3 has basically unlimited storage. Yeah. You can store any file type, and these file types are stored in containers called buckets. All right. So files can be anywhere between 0 bytes and 5 terabytes. That's quite a lot. Yeah. So S3 buckets are regional. And get this, note this for the exam. Their namespaces, yeah, what you choose to name your bucket must be globally unique, right? On to S3 storage classes. So these are the various S3 storage classes. We'll go through each of them in detail. So there's the S3 standard, there's S3 intelligent tiering, S3 standard infrequent access, S3 one zone infrequent access, S3 glacier instant retrieval. Note this one. This is a relatively new tier that I think was added maybe 10 months ago. So note that, I'll explain it. S3 Glacier Flexible Retrieval, formerly known as S3 Glacier, S3 Deep Archive, and S3 Outposts. So there's the S3 standard, as we mentioned. This is durable storage for your frequently accessed data. Yeah. And you want that access to be at extremely low latency. So think of maybe you're a digital media company that is serving maybe movies from your S3 bucket, and there's the movie, this set of movies or series that are being accessed constantly by your users. You'd put them in S3 standard. S3 intelligent tiering. This is ideal when you have data with random access patterns by your users. So if you can't predict what kind of pattern they'll have when accessing your data, you can use intelligent tiering to automatically move your data to the most cost-effective tier. This is based on machine learning. Yeah. There's also S3 standard infrequent access. This is basically durable storage, yeah, for infrequently accessed data, all right, at low latency. So this is much cheaper than the S3 standard, which is for frequently accessed data. There's also one zone, infrequent access. This is similar to the standard infrequent access in that the data is infrequently accessed, yeah, and it has a lower latency than the standard, but the difference between the standard infrequent access and one zone infrequent access is that the data is not replicated across availability zones. So there's less resilience to your data. Please note that. All right. So this new tier, Amazon S3 Glacier Instant Retrieval. Okay. Now, when we move into the Glacier service, we're now dealing with archives. You remember what I told you about archives? Archives are basically data that are very infrequently accessed and they're stored for the long term. All right. So Glacier is used for archiving your data. All right. So there's Glacier Instant Retrieval. This new feature allows you to store your archives, but access them at low latency, access them in practically milliseconds and retrieve them. So note that. There's also Glacier Flexible Retrieval, yeah, formerly known as S3 Glacier. This is basically your archived data storage with your retrieval time ranging from minutes to hours. I want you to note this down if you have a pen and paper. I want you to go look at S3 Glacier Flexible Retrieval. There's the standard retrieval. There's, I think, no, actually, there's a correction. There's expedited retrieval. Write that down. Expedited retrieval. There's also standard retrieval, and I think bulk retrieval. So read on those. They may come in the exam. Okay. S3 Glacier Deep Archive. All right. This is the lowest cost archival storage. It's for very long retention of your data. Hence the fact that it's so cheap because you access that data rarely, right? So data retrieval is within hours, I think 12 to 48 hours. Then there's S3 Outposts. All right, so I'll deal with AWS Outposts towards the end of the presentation. So AWS Outposts at a high level is basically your ability to access AWS, or rather put AWS services within your on-premise data center. So S3 Outposts delivers your S3 object storage to your on-premises. You can have that infrastructure in your AWS Outposts environment in your data center. All right, so when you receive the slides, you can go through this table to highlight the difference between the multiple storage classes. There's also S3 transfer acceleration, all right? So let me begin with an analogy. You're probably familiar with the shoe store called Bata. Here in Kenya, there's their headquarters in Limuru. So let's say they manufacture all the shoes there, or maybe assemble all the shoes there. So how do they reach to different parts of the country? How do they reach Nairobi? How do they reach Mombasa, Kisumu, and serve their customers in those regions? They have branches, these outlets, Bata outlets, to serve their product to the consumer. So picture this CloudFront edge location as a branch. So basically, CloudFront is, I don't know if you've handled in the previous session, but CloudFront is your content distribution network. So you can imagine where your items are being hosted as the headquarters. Then now CloudFront edge locations are your branches where they bring your product closer to the consumer. All right. So now let me explain S3 transfer acceleration. Okay. So AWS has all these branches or CloudFront edge locations all over the world. Yeah. And they're very close to the users. So these edge locations can be used as some sort of network to relay things through it. So that's how transfer acceleration works. You want to upload a file to S3, but you want to do it fast, very fast. You can use the network of edge locations, of CloudFront edge locations, to create an optimized network path from you to your S3 bucket instead of using the internet and latency, yeah, and it might take a lot longer for your files to reach. Now, static web hosting that I mentioned earlier, right? You see, when you typically visit a website and you're presented with the web page, let's say the home page, that's usually like a HTML file, or I think my programmers can put it in better words. So you have these static files like your index.html and then your error files, your error.html. You can store them in S3, yeah, then enable static website hosting on your S3 bucket, and they can be accessed from your users through, you remember we talked about CloudFront, that distribution network, yeah, to your end consumer. Then we'll handle this at the end. Route 53 is basically your DNS server to resolve that domain name into an IP address, yeah, or rather resolve it to a subdomain, yeah. All right, so that's how S3 static web hosting looks like in an architecture. We also have replication, yeah. You can replicate objects in your bucket in one AWS account to another AWS account, or even buckets of the same AWS account. Yeah. No, actually, for different AWS accounts. Yeah. You can have it in the same region. For example, this is in the Singapore region. So objects are uploaded in the source bucket, which is this one, and are replicated to the destination bucket in the same region. But what if you want to replicate across regions? Yeah. As you can see, this bucket is in Singapore, this other one is in Tokyo. Yeah, you can replicate that data to the bucket in the region far away from your source bucket. All right, things to note about replication. For it to work, you need a feature called versioning to be enabled. What's versioning? It basically allows you to store multiple copies of the same file in your bucket. All right, we're done with storage. So let's move to VPC. If at all you're multitasking during this presentation, I advise you maybe stop and focus here, because there are a lot of diagrams and they'll really help you understand the concept a lot better. So pay attention, pay attention. So VPC, Virtual Private Cloud. What is VPC? It's basically a logically isolated virtual network assigned to your AWS account. Okay, what does that mean? Let me give an analogy. Let's say AWS owns, different regions. Let's say it owns Nairobi, it owns Nairobi County, Kiambu County, yeah? let's zero in on Nairobi. AWS owns this region called Nairobi. Then you want to buy land in Nairobi from AWS. Yeah. So it demarcates for you a plot of land. That large plot of land, you can call it your virtual private cloud. Yeah. Assume the VPC is that huge tract of land. Right. So the VPC is analogous to having your own data center in the cloud. It allows you to launch your AWS resources and control their accessibility within your network. Okay, so this piece of land called a VPC that AWS has given you, you're free to, build as many houses as you want and whichever type of developments you want to do within that piece of land. Okay, so it's created within an AWS region and spans all availability zones. So picture this piece of land and it's spanning through, you have a piece of every single sub-county in the county itself. So this land cuts across all the sub-counties. So you can look at those sub-counties as your availability zones. All right. So this land, when AWS gives you this land, you want to say, give me such and such amount of acres of land. Yeah. But in cloud, instead of calling it acres, we call it a CIDR block, classless interdomain routing. Okay. So this is basically an IP address range that defines the extent to which your VPC covers from a networking perspective, right? So the VPC can be further partitioned into sub networks known as subnets. Okay, so we have our piece of land. We can divide it into smaller subplots, yeah, with their own sizes or CIDR ranges in this case, yeah. So let's say you have 100-acre plot. You can divide, one division is 50 acres and the other one is 50 acres. Yeah, you can't use any more than the land that you have allocated. Right? So subnets can either be private or public. Okay, so you can either have, from the land analogy, those subdivisions, that land can be private land which is limited in its accessibility, or public land which is open to the public. So this is kind of an illustration of what I mean. So you have this region, assume that's Nairobi County, yeah. Then you've been given that piece of land called a VPC, okay. You've said, I want my VPC to be 100 acres. So you have this CIDR range which specifies how big your VPC is. 10.0.0/16, okay? Then you have this piece of land called the VPC that's this big. You divide it into two plots, or rather, in this case, two subnets, yeah? The /24 subnets that you've divided the land into. Then in those subdivisions, you choose to develop the land, or rather deploy an instance, a compute instance in each. Yeah, I hope the analogy kind of helped to maybe break down the concept. Yeah, so let's move on. So public subnets have a direct route to the internet gateway specified in the route table. All right, so picture the internet gateway as the only path you have in your piece of land to access the outside world, right? So anyone wants to go outside of your piece of land to meet the rest of the world should pass through the internet gateway. And think of a route table. If you've been on the road, you've probably seen these signboards showing, yeah, exit number whatever, going this way, or Gatundu, turn left. Yeah, you can think of those as your route table. They determine how traffic moves within your network, right? Right. So resources in public subnets have public IP addresses, yeah, that are routable across the internet. They can be accessed through their public IP addresses. You can also assign permanent public IP addresses to your resources. These permanent public IPs are known as elastic IP addresses, right? Now on to private subnets. Private subnets do not have a direct route to the internet gateway. Keep that in mind, right? Resources in private subnets communicate to each other via their private IP addresses, right? So we've already said they don't have a direct route to the internet gateway, so they can't directly access the internet. So what happens when you want a service that's available in the internet for your resources in your private subnet? You use something that's called NAT, Network Address Translation. You can read that link once you get the slide. So this thing called NAT, what it basically is what it is, that it is a feature that transforms your, or rather translates your private IP addresses into public IP addresses. You remember, the public IP addresses can access the internet, but the private IPs can't. But you have NAT. NAT translates those private IPs into a public IP that's routable, right? Okay, so the devices that perform this NAT that we talk about, there's a NAT gateway and a NAT instance, right? The NAT gateway is preferred since it's a fully managed service by AWS. And even more importantly is that it can scale its bandwidth automatically. So meaning even when there's a lot of traffic passing through your network, it can scale accordingly. A NAT instance is basically an EC2 instance in a public subnet. Mind you, the NAT gateway is also deployed in the public subnet. A NAT instance is an EC2 instance in a public subnet with the ability to perform NAT. Okay, so a NAT instance involves additional management. You have to manage the instance itself, the infrastructure. Yeah, it's a lot of overhead. And also there's a bandwidth limitation because we said that it's an EC2 instance. So there are certain constraints to its bandwidth capability, okay? So this is how the NAT gateway looks like in your environment. We've said you know what a VPC is, as we've discussed. Then you have your availability zones, and your subnets are within the availability zones, yeah? So you want these instances in your private subnet to access the internet, okay? So you can't do that directly. You do it through the NAT gateway provisioned in the public subnet, yeah? Yeah, and another thing, maybe this is not too relevant for your current certification, but for future certifications, is that the NAT gateway has to be deployed in each availability zone. Yeah, right? Yeah, for redundancy purposes. In case maybe one availability zone fails, you can still use this NAT gateway in the other availability zone, right? So onto the security section of your VPC. So you have this piece of land you've developed, you've divided it into plots, and in those plots you've built your different houses. Some are publicly accessible, some are privately accessible. Now you want to secure these houses, okay? You can hire a watchman to watch the house itself, yeah? And you can hire a watchman to watch the entire plot of land that, houses your development, okay? So when we think of network access control lists or NACLs, they operate at the subnet level. So that subdivision or that plot of land that you've subdivided, assume there's a watchman guarding that entire plot of land. That one you can refer to him as an or her as a NACL, okay? So there are firewalls that regulate your inbound and outbound traffic. So a feature about NACLs are that they are stateless, okay? This means that you have to explicitly define both the inbound and outbound rules, yeah, and ensure, in order to ensure return traffic. Security groups are at the instance level, yeah. So think of this as the security guard at your building itself, at the building itself, okay? So security groups are at the instance level. They are firewalls that regulate inbound traffic. Okay, note the difference between security group and NACLs is that the security group, you only need to define inbound traffic, okay? Yeah, because security groups are stateful. This means that the return traffic is automatically allowed if you allow inbound access. Please note that for the exam. All right, so how does this look like in your architecture? Okay, I know there's a lot going on, but I want you to focus over here where we have our private subnets, okay? You have the subnets or the subdivision piece of land in your real estate, okay? So at the subnet level, there's a network access control list. Then at the instance level, yeah, at the instance level, you have your security group, okay? Yeah. VPN, virtual private network, yeah? This is basically your own private connection to another network via the internet. Yeah, note that. It's a private connection via the internet. So this is achieved by setting up a VPN tunnel between your VPC and maybe your on-premises data center or even another VPC. It's very quick to set up and cheap, yeah. But it suffers from performance fluctuations of the internet, yeah. We don't have control of how the internet performs. So your VPN connection might suffer the performance limitation of your network connectivity. All right, so how does this look like in the real world? Okay, I know there's a lot going on, but just follow me. There's a data center, okay? So you want a private connection to your VPC, yeah? You deploy this thing called a customer gateway, okay? And in your AWS cloud, you deploy a virtual gateway, yeah? So this is how you establish your VPN connection. You create a tunnel between these two devices, okay? That's your VPN. So yes, it's passing through the internet, but it's private. Yeah. So direct connect. This is still in the line of private connection between your on-premises and your VPC. So instead of going through the internet, which has inconsistent performance, you can have a dedicated line between your VPC and your on-premises network. Yeah. Think of this as your own private road from your piece of land to someone else's piece of land. And that road cannot be used by anyone. Okay. So this takes time to establish since it involves laying cables, but it's fast. Once it's set up, it's fast, reliable, and very consistent because you're the only user. You're not sharing it. Okay, this is how it looks like within an architecture. All right. Again, a lot is going on, but we'll go step by step. There's your data center. Okay. You want a private connection between your data center and your VPC. Okay. So you have your customer gateway. All right. But look, or rather notice that there's a difference between this and the VPN. There's this third party location. Yeah. It's called a direct connect location. It's basically maybe a data center for an AWS partner. Yeah. So you connect your customer gateway to the customer router in this direct connect location. Then within the location, the provider does something that's called a cross connect to the AWS router. Okay. Then this is connected to your virtual gateway in your VPC. That is what a direct connection looks like. It's just to give you a visual illustration, so don't feel overwhelmed by the sheer amount of things that are going on. It's just basically to show you how it looks like. All right, VPC peering. Okay, so we're speaking about private connections between your entities. Okay, so VPC peering allows two VPCs to connect over the AWS network. Okay, notice we dealt with VPN that connects privately through the internet. There's also the, what's it called? The direct connection, which is a private line from your on-prem to AWS. And now we have VPC peering, which is a connection between VPCs through the AWS network. Okay. So some conditions about VPCs that you need to keep in mind. The peered VPCs shouldn't have overlapping CIDR ranges. I'll show that in a diagram. Okay. If you have CIDR ranges that overlap, then that peering connection is not possible. So a peering connection is non-transitive. This one, I think you'll understand once I move to the next slide to show you a diagram. This means that you can't route traffic through a peered VPC to access a different VPC. I'll show that in the diagram, don't worry. For transitive routing, which is impossible in VPC peering, we use a transit gateway. That one I'll handle just after this. So this is what I meant by a VPC peering connection. You have this VPC, the first VPC. It has the CIDR range defined, yeah, 10.0.0.0/16, okay? And you also have this other VPC with its own CIDR range, yeah? So you see, they're different. If they were the same, this peering connection couldn't be possible. But the fact that they're different, the peering connection is possible, okay? So these devices can communicate with these devices and vice versa. Okay. Oh, I forgot to put, okay, let me try explain. What I meant by non-transitive, I forgot to put that image in the slides. So let's say you have this VPC A, okay? Imagine this title is a VPC C that is also peered to VPC A, okay? but there's no connection between it and VPC-B. You can't communicate through A to C through a VPC peering connection. It's non-transitive. What you have to do, you have to connect this VPC-C to VPC-B, okay, in order for VPC-B to communicate with it. Yeah. All right. That's what non-transitive means. All right. So what happens if we do want a transitive communication between many VPCs? We have many VPCs in our environment, or even we have other networks on premises. So we use what's called a transit gateway, a TGW. A transit gateway basically connects multiple VPCs and on-premises networks via a central hub. It's a regional resource, yeah? So it's located within a region, but it can be paired with other transit gateways in other regions. So let me show you a diagram, okay? Fine. Again, there's a lot going on, but notice this. You have your multiple networks. You have several VPCs in your cloud, 3 of them. You have also your data centers, yeah? All right? But you want all of them to communicate with each other, okay? So this can communicate with this, and this, and this, and this, yeah? So you can achieve that through a transit gateway that allows transitive routing, yeah, in a centralized hub, okay? So what I meant by this last point of it can be paired with other transit gateways in other regions is that assume you have this region with its transit gateway and another similar region like this with its own transit gateway. If you want them to communicate, you pair the transit gateways, right? I think I may add a diagram before we release the slides to just elaborate that further. Okay, AWS Outposts. You remember this from S3 Outposts? This is basically a service that allows you to deploy your AWS infrastructure on premises. Basically, you can extend your VPC, your private cloud, your data center in the cloud to your actual data center, your on-prem data center. This is how it looks like, okay? Again, a lot going on. So notice, this is your cloud environment, okay? This is your cloud environment. You have your subnets and your infrastructure and stuff within your cloud environment, and they're housed in a VPC, okay? So you want this AWS infrastructure, but you want it in your data center, okay? Therefore, you deploy something called AWS Outposts, yeah? So it's basically infrastructure that AWS delivers to your data center that's used to host AWS services. So that's how you can extend your VPC into your on-prem data center. I hope that makes clear. All right, now to the final topic, Amazon Route 53, okay? Let me begin with a short story. Growing up as a kid, we had a landline in our house, and underneath that landline was a book that looked like this. I don't know if any of you are familiar, or maybe I'm just exposing my age. There's a book called Yellow Pages underneath that landline. And I was told that that book is called a phone book. It's where you find the numbers of the people that you're looking for. And also around the same period as I was growing up, my mom used to carry a book that looks like this. It was her own personal phone book, though her handwriting is better than this. This is not hers. But as you can see in this one, there's a portion for name whoever it is that you whose contact that you store, and their telephone number. This was way before, we have inbuilt contact lists on our phones. So back in the day, phone books were what were being used. So you have the name, which is pretty easy to remember, but then you have the number, which is a bit harder to remember. So DNS, or domain name system, is like a phone book for the internet. You're probably familiar with www.google.com. Think of that as the name in the phone book. Then that domain name resolves to an IP address, which is a number analogous to the telephone number for that server that's hosting www.google.com, the website, right? Okay, so notice there's a hyperlink here, a very beautiful article by Cloudflare about DNS if you want to really understand it. So DNS is a naming database. Database is basically somewhere you store your information. The same way as this yellow pages stores contact information, or this personal phone book stores contact information. So DNS is a naming database where human-friendly internet domain names like google.com are located and translated into machine-readable IP address. So the server understands 10.0. whatever, but you as a human, you understand google.com, yeah, all right? So DNS helps translate that google.com into the IP address. So as I said before, it's basically the phone book of the internet. All right. So what is Amazon Route 53? Now that we've understood at a high level what DNS is, Route 53 is AWS's managed version of the domain name service. So AWS have multiple DNS servers that help resolve these domain names into IP addresses. They have a large network of them. So they organize all those servers into a service known as Route 53 that you use. All right. So case in point, sorry. Users are asking, where is abc.com? Yeah. The DNS resolver in the internet service provider says, let me ask the authority, the authoritative DNS server, which is Route 53. Yeah. So Route 53 knows the IP address that corresponds to abc.com. It's 192.0.3.2. So it sends that to the DNS resolver and forwards it to the users so that they can communicate directly to that server. Okay. All right. So some of the capabilities of Route 53. It enables you to register your domains. Okay. It also is a domain name service, as we've said. It is a global network of authoritative DNS servers that you can use. It also allows for health checks. All right. These are basically, you have your Route 53 server and your resources in the backend, maybe your load balancers or your instances, your EC2 instances. And it wants to ensure that if I'm forwarding this guy who's asking for this domain to this IP address of this server, I need to make sure that that server is operational. So I'll constantly be checking up. Are you okay? Are you okay? Are you okay? All right. So this health check is an automated request, yeah, sent to those resources to ensure that they are available and they are ready for service. And that is the end. I know that was a lot of information, but thank you. Thank you for your patience. Yeah. All right. Let me. Okay. So you can see my screen. Yeah. Okay. So this transit gateway, you can define it through the route tables. Yeah. You have to actually manually define the routes to the different subnets that you want to access. But okay, let me try see this diagram. Um, okay, like this route table can access maybe your head office via the transit gateway. You define it in a route table. So this IP address will route to the transit gateway attachment, which is this connection. Yeah,
Okay.
right.
Oh, nice. Yeah, I'm now
Yeah,
seeing.
yeah. So if you want to route to there, it'll use that. So it's even defined here. Um, Okay, so we want to route to this address on-prem 192.168.0.0/16. So we want to route from our network here, like let's say one of the VPCs. Yeah. So
Yeah.
in its route table in the subnet, you you input that side range 192. If you want to go to 192.168.0.0/16, use tgw attachment 1, so it will go, yeah,
Oh, okay.
and
Nice.
up to the, yeah.
Okay. The point is at home. Yeah. Thanks for that.
Mm.
Okay. Is there any other question? All right. If there is no any other question, maybe if you come with a question, you'll just drop it at the chat. Then we'll respond to it later. I would love to welcome Zipporah Washira for a lab session so that we can relate the concept that Miano has shared with the lab itself so that we can see how is this theory being translated to a lab and in a real world scenario. ZP, she was introduced yesterday. For the purpose of repetition, there's no harm in repeating. Zipporah Washira is a AWS solutions architect at Silicon Overdrive. Silicon Overdrive is a South African based company and they have come to Kenya. I guess you have heard stories about AWS coming to Kenya, and Silicon has also joined the journey of coming to Kenya. It's now in Kenya. So, ZP, are you in a position to take us through short lab session before we call it a day?
Absolutely.
Nice, nice.
Yes. Okay. Good evening, everyone. I trust you guys are enjoying the session so far. So, today we are going to do just a short lab session that's going to be based on what my colleague, yes, on what Miano was talking about. So, let me just share something. Mhm. Yeah. So, with a focus on the networking principles of AWS Cloud, I believe he's covered it quite extensively. All the basic concepts that you need to understand when it comes to networking within AWS. So, we have all these things VPC, we have the availability zones, and the global infrastructure, I believe, was covered yesterday by James. And the gateways have been covered by Miano. So I hope by now you understand the essence of, for example, this is an internet gateway. Why would you need an internet gateway in a VPC? Why would you need a NAT gateway? What is the essence of having root tables? So we are going to do a very simple demonstration, starting with how you actually create a VPC, how you create the subnets within these VPCs. So just something to add on is that I mentioned this yesterday, and what I said is in AWS, any resource that you launch, it always has to be deployed within a VPC. So a VPC, it's kind of the underlying, let me say, it's like a container that holds, it's literally a container that holds all your resources. So it's quite important to understand how to configure a VPC or to create a VPC, because you cannot always use the default VPC. And within this VPC, there lives subnets. We have public subnets and private subnets. And really, the difference between the two is that a public subnet is accessible from the internet and a private subnet it's not. It's more restricted. So if you are deploying something that is a bit sensitive, you'd have to deploy that to a private subnet. And if you are deploying something that is not as sensitive, you can just deploy that to a public subnet. An example is a web server is something that you want anyone to actually access it. So that one can easily be deployed in a public subnet. But something like a database server, that is something that holds very sensitive data. So that's not something you want to expose to the public. So ideally, that's an example of a resource that you would have to host in a private subnet. And then internet connection or connection to a public network in AWS, it's always enabled by an internet gateway. So if you want that access from a public network, you always have to configure an internet gateway within your VPC. And for a private subnet, remember I've mentioned that by default, a private subnet cannot access the internet. So if you want for example, if you're running, let me just, yes, for example, let's say I have a database that is running within this private subnet. Of course, this database is going to require things such as patches and upgrades and all that. And I want to be able to do this remotely. So what I need to do is I need to have a way to actually remotely access this subnet, but at the same time, I want to make sure that it's still protected from accessing a public network. So that is where NAT gateways come in. I believe he's also covered that quite exhaustively. So these are just some of the things. I'll do a very short demo to show you how to just create some of these things. And yes, if you have any questions during the demonstration, feel free to post them in the chat or just raise your hand. Albert, please keep a watch for me. Okay, thank you. So here we are. This is the AWS Management Console, and specifically, this is the VPC console. So this is where we are going to start. And first thing is we are going to create a VPC. Let me just go from, yes. So this is what the VPC dashboard looks like, the very basic one. So you can see here, it's a list of all the VPCs that are in my account. And remember that by default, every AWS account that you create, it always has a default VPC. And within that default VPC, there's some default subnets. And these are usually public subnets that are created in all the availability zones in your account. So to confirm that, or if you want to just verify that, you can just scroll and there's this tab over here that says default VPC. So you can see it identifies, is this a default VPC? Yes, so this is my default VPC, and this one it's no, because this is a custom VPC that I created myself. So yeah, that's just for confirming. Then you can see the root table that is associated with that VPC. You can see some DHCP options. We look at those later. And of course, each VPC it's associated with an IP CIDR. Yes, so let's create our VPC. So we click on create VPC, and we only want a VPC.
And we only want a VPC.
Paul, kindly
Paul,
mute.
kindly mute.
Thank you. Oh, hearing your voice is so unsettling. Okay, so first things first is we give the VPC a name. For example, this one I'm just going to call it a test VPC. Then we specify the addressing scheme that you want to use. In this case, I want to use an IPv4 CIDR, and I want to specify the address range that I'm going to use for this VPC. So something. Let me just duplicate this. Okay. So here what I need to do is I need to input a CIDR range that I'm going to use for this VPC. And I don't know how many of you are conversant with IP addressing schemes and subnetting. I can't go into details about this at the moment. So what I'm going to do, I'm just going to share a link, but for now, I'm just going to input an example of a CIDR range that I can use for this particular VPC. So what you need to note is that it shouldn't overlap with any other CIDR that is there within your VPC. So in my case, my default VPC, it's using the 172.31/16 range. And my custom VPC, the one that I already have, it's using the 10.0.0/16 range. So for this new VPC that I'm creating, I need to select a CIDR that does not overlap with whatever already exists in my account. So I'm going to give this 1.0.0.0/16 CIDR range. And then I don't really want an IPv6 CIDR block at the moment. I only want IPv4, so that's it's okay. So now we create our VPC. Awesome. Okay, so now we have our VPC. This is the VPC we've just created, test VPC. You'll notice once you create it, it's automatically assigned a VPC ID, and its state is it's in the available state. You can see the CIDR for whatever we've just selected as the IPv4 CIDR, and a couple of other details, DHCP options. We have the main root table. This is another thing that it's automatically created for you. So the main root table, if I can just show you, you'll find that at the moment it only has roots. It should only have a single root, and it's a local root. A local root basically means it's just a root to the VPC itself. So you can add a couple of roots here as you create more VPs. Sorry, as you start to create your subnets. But at the moment, I'm going to leave this as it is. But what's something to note is that Once you create a VPC, there is automatically AWS creates a default route table for it. And within that default route table, there is a default route to the VPC or to the entire network of the VPC. So the next thing we are going to do is we are now going to create a subnet. And now remember, there are two types of subnets. You can have either a public subnet or a private subnet. Yeah, okay, let me change this. Yes, so you can have either a public subnet and a private subnet. So I'm just going to create two subnets, then I'll show you the configurations that actually make each a public or what makes it a private subnet. So we'll go to create subnet. Subnet lives within a VPC, so you have to specify the VPC where you want this, where you're creating this subnet. In our case, it's the test VPC. Then you can give it a subnet. I want this. This will be my private test subnet. And an availability zone, which as you can see is optional. If you don't select a zone, it's automatically created in one of the availability zones. So I'll create this in US1A. Then I now have to specify a CIDR block for my subnet. So with this, what you need to know is remember that a subnet lives within a VPC. So whatever address range you give to this subnet, it has to be within the address. Let me just, yeah. It has to be within this address range that you specified for a VPC. For example, if I try to create a subnet within this VPC and I give it an IP address in the 10 range, you'll find that I'll get, and let me actually just try that. It should give you some kind of an error. .0.0/24. So you can see the error is CIDR address. It's not within the range from the VPC because my VPC it's within the 1.0.0.16 range. So your subnet, the IP range for your subnet or the CIDR block for your subnet, it has to be within the CIDR range for your VPC. Now that we have that should be fine. So let's create that subnet. And so that's going to be a private test subnet. Let's create a public one, same VPC. This will be the public test subnet. Create it in the same zone. Again, this one, it also has to be within the same range. So I'll just give this under 0.0.1, maybe /24. And again, if you are not very familiar with or you don't have a very good understanding of subnetting, I'll share some links later on, which I hope will just make this a bit more clear. So let's give that range. Sorry. .1.0. Yeah, that's fine. And see. Okay. Yes. So we have our two subnets that we've created, public test subnet and private test subnets. A subnet public essentially. Really? Again. Okay. I'm sorry for that. Okay. So what makes a public subnet public? It's that it needs to have a route to an internet gateway. So any subnet that has a route to the internet gateway, that is a public subnet. But for a private subnet, what it needs is you have to create a route to a NAT gateway. Remember, a private subnet cannot directly communicate to the internet gateway. So for the private subnet, we are going to create a NAT gateway, and then we are going to add a route in the route table that points to the NAT gateway. Then for the public subnet, we are going to create an internet gateway, and we are going to add a route within the route table that points to the internet gateway. So let's do that. So first, let's start with the public subnet. What we need to create is an internet gateway. So just come to internet gateway. And before this, let me just show you something else. I want to show you the default route tables. Before I add any routes, let me show you what the route tables for these two subnets look like at the moment, so you can see the routes that are there. So this is private test subnet, and this is the route table. Notice that right now it only has a local route, which, as I mentioned, this one is created automatically by AWS once you create the subnet or once you create a VPC. And you'll find that also the public test subnet that we have, it should also have only that one route, and it will be a local route. This is the wrong subnet. Yes, sorry. Yeah, this is it. Private public test subnet. So again, you can see it's the route table. It only has the local route. Okay, so now let's go and create the internet gateway. So on the menu, just click on internet gateways, then create an internet gateway. So for the internet gateway, all you need to create is, actually all you need to specify is the name. So let me call it my internet gateway test. And then we create the internet gateway. The next thing is you need to attach this internet gateway to a VPC. Notice in this architecture diagram, the internet gateway, it's attached to a VPC. It's not attached to a specific subnet. And this is because an internet gateway, it works, it's like a shared, actually it's a shared resource. Notice that it's used by both availability zones. Basically, all resources in all availability zones within a VPC, they will share this one internet gateway. And that's why it's actually attached to a VPC rather than to a subnet. But for the NAT gateway, as Miano mentioned, a NAT gateway, it's assigned per availability zone. So this, while it's very possible to have this, no, sorry, actually it's not possible. So yes, the NAT gateway, it can only function or it can only serve a single availability zone, and that's why we only attach it to a specific subnet. So for the internet gateway, we will attach it to our VPC, and that's the VPC, attach the internet gateway. So there we go. Now, the next step and the final step for this is now we need to add a route in the route table of our public subnet that tells it if you have traffic that is destined to the internet, send it to the internet gateway. And how you do that is, here we have public test subnets. Let's go to the route table. So you can see we still just have that one single local route. So at the moment, this subnet still cannot communicate with any public network because it doesn't have a route that points to an external network. So what you do is you have to edit the association. This is my route table. No. Sorry, a moment. Yes. Yeah. So this is the route table for the our public subnet. So you click on let me just redo this. think I lost someone somewhere. So go to the root table. Let me start from the subnet. So starting from our subnet, what we want is this subnet. Here we go. So we need to pick the root table. That's the root table. And now from the root table, what we need to do is to create or to associate, create a new association. My subnet associations, edit. Oh, sorry. Yeah, there we go. Sorry, Albert, please confirm if I'm resharing my screen.
Yeah,
I
yeah,
think I
sure.
disconnected for
It's
a bit.
coming up.
Oh, okay. Awesome. Okay. Then, as I mentioned, now what we need to do is we need to add a route that points to the internet gateway that you've created. So on routes, we click on edit routes and we add a route. So our destination is a public network, and usually a public network is identified by a CIDR range of 0. This means any network. Basically, any network that's any network. If you want to access any network, and the target in this case, it's an internet gateway. So when you click on the internet gateway, it will bring you a list of all the gateways that are not attached to any subnet. And in my case, we have the internet gateway that you've just created. So you just select that and you save changes. So now, if I go back to my public test subnet over here and I check the root table, you can see now we have a new route and the destination is the 0 CIDR and the target is to the internet gateway. So now any resource that I launch within this subnet, it cannot be able to access the internet because we have a gateway that will route that traffic to the internet, to the internet. So that's the first part. So we've created this internet gateway and we have associated it with the VPC, and we have created a route within our public subnet to direct internet-bound traffic to the internet gateway. So the next thing we are going to do is we are going to create now a NAT gateway for our private subnet. And again, on the menu, just find a NAT gateways. This is the console for the NAT gateway. Same procedure, create NAT gateway. You give it a name, say NAT test, NAT gateway, NAT test gateway. Why not? NAT test gateway. Now you need to specify which subnet do you want to associate this NAT gateway with. So we want to associate it with our private subnet. So I select the private test subnet, the private subnet basically. And then you have to select the connectivity for your NAT gateway. So it can, oh, sorry. No. Oh, yeah. Okay. Yes, you have to select the connectivity type for your NAT gateway, which is can either be public or private. So public basically just means this NAT gateway will enable traffic from the internet to reach your private subnet, but usually this traffic is one way, which means resources in your private subnet, they won't be allowed to reach or to send traffic outside. It's only a one-way kind of an access. So that's why I said this is only important, or it's necessary when, for example, you need to do things such as patches or upgrades on a resource that currently resides in a private subnet. So yes, you'll be able to access this resource from the internet, but this resource will not be able to access the internet. That is the access that is actually blocked by this NAT gateway. So we'll make it public, and then a NAT gateway that a public NAT gateway always has to be associated with an elastic IP address. And an elastic IP address, it's basically a static public address. So I don't think I have one. So I'll just create on allocate, and by clicking on allocate IP address, an EIP is created for me and automatically it's attached to my NAT gateway. So that's that. We create our NAT gateway is created. Mhm. Oh, no, okay. Private test. Sorry, just a moment.
Okay, as ZP is sorting it out, at least we are now relating the concept that Miano had shared. We are now trying to get the theory into the lab into a practical way where we see we have the various public subnets, the private subnets. I guess by the end of this lab, we should be able, I'm challenging us, all of us, by the end of this lab, we should be able to know what defines a subnet as a public subnet and what defines a subnet as a private subnet. Yeah, that is an assignment to you. The answers will be mentioned during the discussion, and I want you to get, to know it. It is very key to when you name a when you want to a subnet to be a public. What must you do so that that subnet to be a public, and what must you do for that subnet to be a private? That is a challenge to all of us. You have also seen the concept of VPC, the virtual private cloud, where we say that is a logically isolated space that allows you to provision your resources. Also, any other point that someone has noted as we wait for ZP to come up, you can just unmute and say anything that you remember, anything that comes first in your head. Hello.
Hello, Albert.
Yeah.
I have a question to ask
Okay, sure.
everyone, actually.
All right.
You can feel free to Google, but what's what's the difference between throughput and IOPS? What's the difference between throughput and IOPS? This is what we handled in storage, like in EBS. So what's the difference between throughput and IOPS? You can feel free to Google.
All right. Anyone who wants to take it? Okay, there's no one. The difference between throughput and IOPS, input-output operations. Miano,
Yeah.
I also, maybe what I heard from you, you're talking about low latency. Low latency, whereby you are saying it is the time taken for you to get the information back. So, for the purpose of low latency, I guess you can help them answer the question, because in this way, it seems that you'll take much time before someone can respond to that. So probably you can give it. You tell us, Miano. Remind us. Okay, I see Titus Washira. Titus want to take it over. Titus.
Oh, yeah, okay.
Are you able to hear me?
Yeah, yeah, sure, I can hear you.
Okay, so let me just give it a shot. So IOPS is basically just they can I've googled it, but at least I can just be a little bit more elaborate. So um um IOPS is basically just like the Google has said, count of the read and write operations per second. Basically like how many operations have been done, maybe when you like maybe request for something in the cloud, like how many counts of those commands or requests have you sent, not like the actual data that is being transformed. So the throughput is more of the amount of data, how many like MBs or how many bits are being transmitted. So I think IOPS is basically is more of how many commands or how many like requests have you sent, but the throughput is more of how the amount of data, the quantity of data that is being transmitted through the cloud. So yeah, I think that's my take on that. So maybe Miano can elaborate on that. So yeah.
Uh, I have nothing to add. That was well explained.
Okay.
Okay, Albert, let me conclude. Yes, so sorry for that, guys. So let me just reiterate what we did initially. So we created a VPC, we created the subnets, we created a public and a private subnet, and we've created an internet gateway and attached it to a VPC. We've created a route within the public subnet to point or to direct any traffic that is it's destined for the internet. We've created a route to the internet gateway. We've also created a NAT gateway that's now for our private subnet. So the next step was now to add a route within the route table for our private subnets to direct traffic towards the NAT gateway. So yes, here we go. So same process we went through before. This is the route table for the private subnet, the private test subnet that we created. And again, the traffic that you want to direct in this case, it's the one that's destined for any destination, which is yes, the zero network basically, and you want to send that to our NAT gateway. So this is the NAT gateway that you've created, NAT test gateway, and now we can save our changes. So if I go back to my subnet, now let's look at the private test subnet. There it is. If we now look at the route table, you'll find there's a new route that has been added that is pointing to the NAT gateway. Same thing that happened with our private subnets. And select. For our private subnet, after we added the route, now our route table, it had a route to the internet. This is private or public. So sorry for that. But yes, that's basically the whole concept of it. That's basically how you, in a very simple way, that's how you configure a VPC or you create a custom VPC. I think I'll end there. Back to you, Albert.
Kevin, are you there for a remark? Okay, maybe you're not in a position to unmute. You can have Alvin. Hello. Okay, because of time, maybe Dominic, are you in a position? Or Sharon? Uh, Dominic, you're not in a position? Okay, okay, it's fine. Yeah, so, and that brings us to the end of our today's bootcamp. We'll share the resources, the the presentation. We'll share them tomorrow at the end of the bootcamp. Also, I encourage you, let's also meet tomorrow. Tomorrow will be the last day. Oh, Dominic, you didn't get the question. I was asking for a remark, how you find the session, but it's fine. Because of time, I guess we can end there. I hope you've all found it very interesting, insightful, and very educative. Let's keep learning. Let's keep learning, and let's keep upskilling. Yeah, the program. We are coming to the end of the program. I'm sorry. Is it Kadit? Hello, Kadit. Okay. We'll share. There's a video. There's a YouTube. I'll share the. Let me share. Ojuma, are you in a position you share the YouTube link so that Kadit can catch up with what we discussed today? Maybe
Hello.
let's.
Thank you so much, Albert. First, I'd like to appreciate the speakers of today, Mr. Miano, Anthony, and ZP. Thank you for the great session. Sorry, I was in a bit late, but I'll just say thank you for creating time to share with the community on this second day. And sorry, Kadit. I think there's a problem with the timing because I know you're not using the East African time, so that's why maybe you missed this. But yeah, let me just share the link, the YouTube link, so that you can do a follow up on the recording. Then tomorrow, I'll bear in mind that the session starts from 8:15 to 10:15 East African time. Okay, so maybe if you convert that to the UK time, do that prior so that you don't miss the last day, which is tomorrow. But generally, thank you guys for making it, and let's meet tomorrow. Tell a friend to tell a friend, because tomorrow is the big day. You're going to finish it powerfully, and I wish you well. So let me just post the link to the YouTube channel so that for those who didn't maybe have a chance to view all of it can access via YouTube. Thank you so much, and back to you, Albert. Uh, Sorry, Albert. I see Titus has something to say.
Oh, okay, okay. Sorry, I'll be quick because of time. Just a question about tomorrow's session. Maybe uh, maybe you could like tell us what we would expect to work on, because yesterday was basically the overview. Today we were into like the storage bit. So what will tomorrow's session be about? So that maybe we can have some few resources to look at before we attend the session. So maybe, I don't know.
Okay, so Titus, if you have a look at the email that we sent, it has a schedule for each and every day. So tomorrow we'll be doing billing, pricing, and governance. Then we'll do a lab, and finally we'll do the conclusion. Yeah, so that's the agenda of tomorrow. But in case of any additional thing, we'll let you guys know. And if time allows us, we'll cover more. Okay, but that's for now. That's what we're going to be covering tomorrow: billing, pricing, and governance. Whereby uh, VP Miano and I will be presenting on that and doing a lab. And finally, if time allows, we can do questions, practice questions that you can expect while doing your cloud practitioner exam. Is that okay?
Oh, yeah, yeah, yeah. That's fine. Thank you so much.
Awesome. But one thing that I can advise you guys, if you don't have an AWS management console account, the account that the management console, it's where we use, it's where you can do your lab. Make sure you create one so that tomorrow during the lab session you can also follow up. Yeah, I think that way you will understand it better. Thank you.